Okay, so today we're going to talk about some sorting algorithms. Now, you've probably heard the word algorithm before in your life, and it's nothing all that fancy. What an algorithm is a set of instructions for completing a certain task. And in this way, a recipe could even be understood as an algorithm. And our specific task, when we have a bunch of data or information that we're working with, is to sort that data. And for this example, we're going to talk about elements in a list as our data, in particular a list of integers. So here you see we have a list of integers, and the red color will be used to denote unsorted items, and the blue color will be used to denote sorted items. So imagine we had the task of sorting this list in an ascending order. To do that, it seems pretty intuitive. You would go through the list and say, where is the smallest element? Okay, let me put that at the beginning of the list. And then look for the next smallest element and put that after the one at the beginning, right? And you'd repeat that. And this approach is in fact an algorithm called selection sort. And effectively what this does is build a sorted list one element at a time. So the idea is that we find the smallest unsorted elements and add it to the end of the sorted list, right? But we're just actually working with one list here. And if we wrote that in pseudocode, so if we kind of still using English, not writing code, but we made it sound very code-like, the instructions that we'd have would be to repeat something for every element in the list. So for each element in the list, find the minimum value in the unsorted part of the list, and swap the found minimum value with the first element of the unsorted list. So let's make that a bit visual. Right now the whole list is unsorted, with all our unsorted elements in red, right? So we search through this whole list to find the smallest value, looking at each element from start to end. So we go for index I in the length of this list, right? Look at the first element, so that would be 4. Then we want to look at 1. Is this smaller than 4? Yes, we want to keep 1. Is 3 smaller than 1? No. Is 5 smaller than 1? No. Is 2 smaller than 1? No. Okay, so indeed, it looks like 1 is the smallest value in our unsorted list. So we've completed this first part of the algorithm, right? Now it's the second one, swapping the found minimum value with the first element of this unsorted list, okay? What is the first element of the unsorted list? It's this element here, 4, okay? Here I've swapped values, and now I'm going to color the sorted elements in blue. So we have a distinction between our sorted section of this list and our unsorted section of this list. Keep in mind, visually this is straightforward, right? And I'm trying to distinguish knowing where the start of the unsorted list is, right? That's an important part here. Okay, now let's repeat this process, because that's what our pseudocode says. For each element, we've done that for the first element. The next smallest value is 2, and we swap that with the first value of the unsorted list, which was 4, and so 4 goes into the position where 2 used to be, right? We repeat, the next smallest value is 3, and in fact 3 is also the first element of the unsorted list, right, of the unsorted section, so we're swapping it with itself, which really means it's going to stay in place. Cool. Next smallest one is 4, that would swap with the first element of the unsorted section, which is 5, and then 5 is the next smallest value and of the unsorted list, and it's also the last value, and it happens to be in the correct place. Voila, we've sorted out our list. So now that's all good and well, and I hope that it made sense visually, but how might we implement that in some code? Well, let's go take a look. Here's that list that we just worked with, and here's a bit of that pseudocode that we worked with as well. So I want to open, or I think I might already have open, yes, I'm going to keep this here on the screen. Alright, so let's write a function definition, and we'll call this sorting algorithm are we doing? We're doing selection. So let's call it selection sort, and it's inevitably going to take in a list, right? Some list L that has elements that we want to have sorted. And if we just put in comments the steps that we've got down in our pseudocode there, we've got for each element in the list, array and list are the same thing, sorry about that. For each element in the list, we want to do some things, okay? And the first thing we want to do is find the minimum value, remaining min value particularly in the unsorted list. And the second thing that we want to do, once we have found that, is we want to swap the found minimum value. I'm just going to write here and make a swap. Okay. So how do we write a for loop? How do we go through each element in this list? Well, we'd say for I in I'm using the index, by the way. I'm not going through the elements themselves. I'm going through particularly the index, using the index of the elements in this list. Right. So for the length of this list, we're going to want to traverse through it. And what are we going to want to do? Now, we want to find the minimum element in the remaining unsorted array. Okay, and remember I pointed out to you that we started doing that thing of a blue color for representing what was sorted, so that we could distinguish which section of the list is now sorted and which section is unsorted. And we don't have that kind of visual thing going on when we're writing code. We need to keep track of something else, and what we can keep track of is the index of the minimum value, right? So let's make ourselves a minimum index, and I'm going to set it to I initially. And what is I? I is going to be the counter for the indices in this list of ours, and we can get a bit particular so long as 0, 1, 2, 3, and 4. All right, those are the indices. Those are the values that I will go through, and we're going to set the minimum index to be whatever I is. Okay, because we're just assuming, we haven't made any comparisons yet, and this works for the very first iteration, doesn't it? Because I would be 0, and so the minimum index would be 0, and really what we want to say is, what element is that? That's element 4, and we want to know what the smallest value is in this remaining unsorted list. Okay, so how would we find what is the smallest value? If we can get the value of 4, we want to ask, is that the smallest? Right? And so we want to compare the value at this current index to everything that is ahead of it. So to all of these. And we want to ask for each one of these, are they smaller than 4? And if they are smaller than 4, we want to update our minimum index, because that's in fact a smaller number than this current value, and we want that to be the index for the minimum value instead, so we can move to our swap. So how would we do that? Well, let's make another for loop inside of our external for loop, because we want to go and look at each of the elements ahead of 4. So how would we do that? Let's get an index. We can say j, all right, in, and it's going to be in the range of, well, the same range, but we want to start at wherever the counter I is plus 1. We want to say, okay, well, wherever our current position is, which is represented by I from line 4 here in the code, we want to look at everything that is one position ahead of it to the end of this list. So when I is 0, we'll be looking at this whole section, and when I becomes 1, we'll be looking at that whole section, etc., etc. So we're just saying, okay, when I have this element, I want to look at everything ahead of it. All right. So for j in range of I plus 1, so 1 ahead of the current position that I'm looking at, for the length of my list L. Okay, what do we want to do? We want to make a comparison. We're currently saying that the minimum index is going to be the value that's here at 0. And so we want to say, is 1 smaller than 4? And we want to then ask, is 3 smaller than 4? Is 5 smaller than 4? Etc. We want to look at every element. So we're going to loop through this whole list just to find the smallest value. And so we'd say, if this current value at what we have as the minimum index, if that value is bigger than the one just next to it, which is j, remember j is going to start at I plus 1, so minimum index is currently I, and j will be I plus 1. If this value is greater than the one that comes after it, well, then we need to update the minimum index, because that's actually the smallest number, is actually at index j, because that value at index j is smaller than the value at what we currently have our minimum index saved as. And we're going to go and do that for all of these. So what is the question that you evaluate? You say, if we read this, we'd have I starting at 0, then we're going to have minimum index. I'm just going to use a little dot. My pen gets a bit strange on the screen. I'm going to use the dot for the minimum index. Is currently 0 from line 7. Then we're saying for j, from the values of 1, because it's 0 plus 1, right? I is currently 0, to the end of this list. Is 4, because I'll add the minimum index, which is 0, is 4 bigger than 1? Yes, it is. So instead I want to save my minimum index to be this value, because that's where the index, that's the index of the minimum value. And then I will go on to say, so I set, you see I set minimum index. And then this inner for loop continues. And j increments to 2, and I say, is 1 bigger than 3? No. So I won't rewrite the minimum index. And I'll continue this for loop repetitively until I find a value that is smaller than 1. But 1 happens to be the smallest value in this list. So now I've completed that first step, right? What do I want to do? Once I've found the smallest value, I want to make a swap. Okay? How do I make a swap? Well, I'm going to list first the two values that I want to have swapped. It's A at the position I, right? Which is going to be this 0th position. And what do I want to swap it with? I also want to swap A that has the value of the minimum index. Okay, so the value at this index. I want to swap these two such that A at I, which is technically the 4 here, is going to rather be A at the minimum index, so the smallest value, which is 1, and where 1 used to be, so A at the minimum index, I want that rather to be A at I. So that's how I write a swap. I'm swapping this value, and I'm swapping this value with this value, and I write it on one line. That is the code for selection sort, and if it doesn't make that much sense to you still after this explanation, what I would encourage you to do is write a variable and values table and solve this little example by hand. Oh, what's a variables and value table? Well, what that is just go and take out a piece of paper and a pen, right? And write here, okay, sorry, my pen sometimes freaks out. What is my variables? And what is the value of those variables? And go list I and say, okay, when I is 0, then what happens? The minimum index is set to I, so it's set to 0 as well. Then you create another little table inside here. We have J. J is going to be equal to 1, right? Then you go and make a comparison of L at the minimum index, and we knew that L at 0 was 4, and we say, is that bigger or less than L at J? J is 1, and that was 1. And 4 is bigger than 1. So we went and we rather said, okay, let minimum index be equal to the value of J, which is 1 instead. And then we repeated that in our inner for loop, and we made the swap once that inner for loop was done. So if you're really struggling to understand this, I encourage you to go and just take out a piece of pen and paper and write down those variables. Keep track of how they change while you look at this code, and I'm confident that you'll have a better grasp of how the code is implementing what we just discussed, where we first look through the whole array to find the minimum value, and then once we have found the minimum value, we swap it with the index of we would swap it with the index of I, so the start of the unsorted array. And then it becomes sorted, and we repeat that process. Thank you.